Alright guys, today we're going to look at factoring by grouping. So when we have polynomials, which have four terms, 4 terms, to factor these polynomials, what we do is called factoring by grouping. So to factor by grouping, we simply follow these three steps that are bulleted. First, we split the polynomial into two groups. Then we take the GCF out of each group. We put the GCFs together and rewrite what was factored out twice. We're going to follow these steps to a T, and it should help us factor each of these expressions. So my first example is AB minus 6A plus 2B minus 12. The first step tells me to split the polynomial into two groups. When I put these groups together, I want to make sure that they both pieces in the group have something in common with one another. I'm going to cut this polynomial in half and separate it by red parentheses and blue parentheses. This shows me my two groups. In my first group, I have AB and 6A. Both of those terms have an A in them, so they have something in common. In the second group, 2B and negative 12, both of those terms have an even number attached to them, so I know I can divide both of those numbers by 2. What I'm going to do next is take the GCF out of each group. In my red group, my first group, AB minus 6A, what they have in common is A. And if I take out A, I'm left with B minus 6. I'm going to bring the addition sign down and do the same thing for my blue group. In the blue group, I have 2B minus 12. If I factor out the 2, which is the GCF, I'm going to be left with B minus 6, because 2B divided by 2 is B, and negative 12 divided by 2 is negative 6. Now I'm on to my third step, which tells me to put the GCFs together, which means to write them in one binomial, so parentheses A, positive 2, the plus sign matters. And then it tells me to rewrite what was factored out twice. What that means is I wrote B minus 6 down twice. So I know that my second set of parentheses should have B minus 6 inside. This is the factored form of that polynomial. A way to check is just by taking what you found and foiling. FOIL means first times first, outer times outer, inner times inner, and last times last. I'm right back where I started. So I know that this is the correctly factored form of that polynomial. In the second example, I have x cubed plus 5x squared plus 3x plus 15. Again, I'm going to start by splitting my polynomial into two groups. The first two terms both have x's in them, and they're both raised to a larger power. One's raised to the third, one's raised to the second. I know that my GCF in my first term, or my first group, the red group, should be x squared, because I can divide x cubed and x squared by x squared. If I take x squared out of both of those terms, I'm left with x plus 5. In the second group, my blue group, 3x and 15 have a common factor of 3. And if I divide both of those pieces by 3, I'm left with x plus 5. My third step tells me to take my GCFs, which are x squared and positive 3, and put them together in one group. Then I'm going to rewrite what I wrote down twice, which is x plus 5. I'm only going to write it down once, though. This is the correctly factored form of my expression. In the third example, I have m squared p squared plus m squared minus 2p squared minus 2. I'm going to split these up into two groups again. In the second group, though, I noticed that 2p squared is negative. I have to make sure to include that negative in that group. I can't just leave it out in front. So what I'm actually going to do is rewrite this as m squared p squared plus m squared plus my second group, negative 2p squared minus 2. The reason I put this addition sign is so that I know I have my two groups separated. If I don't put that addition sign down there, I'm more than likely to bring the wrong side down when I the wrong sign down when I factor out my GCFs. The first group has a common factor of m squared. And what I'm left with when I divide is p squared plus 1. Bring down the addition sign. The second group has a GCF of negative 2. And when I factor that out, I'm left with p squared plus 1. So again, I'm going to write down my GCFs in one group. M squared minus 2. And then I'm going to rewrite what was written down twice, which is p squared plus 1. But again, I'm only going to write it down one time. This is the correctly factored version of that polynomial. In the fourth example, I have xy plus 2x minus y minus 2. If I do what I've been doing and split this in half, remember keeping the negative with that y. If I look at my terms, x, y, and 2x both have a common factor of x, but y and 2 have nothing in common. When this happens, what you need to do is reorder your polynomial so that it's aligned so that the groups have two terms, each with something in common. So I'm going to reorder this, and I'm going to put x, y, and negative y together. I'm going to put positive 2x and negative 2 together. So now when I group it, the first group has a common factor of y, and it will leave me with x minus 1. Bring down the addition sign. The second group has a common factor of 2, and it will leave me with x minus 1. My GCFs are y plus 2, so I'm going to bring those together. And then I wrote down x minus 1 twice, so I'm bringing that down as well. Alright guys, this was factoring by grouping. Have a great day.